Hey everybody, welcome to another episode of Decodable's Demo Days. My name is Eric Sammer, I'm the CEO and I'm founder here at Decodable. And today we're going to be talking about, this is actually the second part of a series on working with change data capture data. And I'm going to be building on our previous demo on how you can attach to the source of change data capture data and process it. Now I'm going to show you the second half of that, which is really like, sort of pick up from the processing stages and then show you how you can write CDC data or change data capture data back into other systems. And today I'm going to continue to use the same tech stack that we used in the last demo, which is using Postgres inside of AWS, RDS. So if you haven't checked out the first half, please go check it out. We sort of show off, all the different ways you can attach source tables and process that data in real time. Let me go ahead and share my screen. So today, like I said, we're going to be picking up kind of where we left off. And just to remind everybody, what that looks like, we have a connection here in Decodable. That is attached to our Postgres database, which I'll show you in a sec. And we see some connection information to our Postgres database, our host, our port, the database name, schema, all sorts of stuff that you would be really familiar with, if you're familiar with Postgres. This, of course, is database specific for MySQL, for Postgres, for bunch of different systems. You'll see different connection information. And this is reading the changes to the users table that we have inside of our Postgres database. Let me flip over and just show you real quick what that winds up looking like. So here's our Postgres database. We have a users table, and you can see that it has an ID, a username, an email address, status, and then a pair of timestamps, one for the created time and one for the updated time. So the time we've initially created our user and then any changes that have occurred to that user, which will be important in just a little bit. So this is our source table. And you can see that schema, let me zoom out just a little bit here. That schema from that table is actually replicated here in Decodable. So we have all the same type information, the constraints, in this case, not null, and a bunch of fields. And we've designated this ID field as our primary key. And so this data you can see it's not processing a ton of data. We've processed 57 records thus far. This is actually outputting to a stream in Decodable, which acts as the flow of data that's coming out of the Postgres database. So I've pushed some data through this, but I'm actually going to show you just real quick what that winds up looking like. And then we can sort of hop into the second half of the demo. So we have 57 records that have flowed through the system thus far. I'm going to switch over to Postgres, and off screen, I have a couple of SQL statements that I'm just going to copy so that you don't have to watch me type. And just to sort of show you, again, that there's kind of nothing up my sleeve, there's nothing in this table, right? This is an empty table, no records in it. I'm going to paste in here some initial record population. So I'm going to insert 3 records, eSummer 1, 2, and 3 as our username, and 1, 2, and 3 as our email address. And we're going to set the status of these users to active. We're just pretending that the status means something in our application. And I'm going to set both the created date and the updated date to now, because that would be what our application would do. Okay, so we've inserted those records. And if we query the table, we can see those records. The timestamps are slightly different, based on the insertion time, as you would expect. Everything sort of looks normal. And if we flip over here, you can see that this is actually already increased to 60 records. Remember, it was 57 before. So our handful of records, or 3 records, have flowed through this connection already, and you can see that it's about 0.05 records per second. So it's processing data pretty quickly. And so if we look at the stream, and again, the stream is, if you're used to dealing with databases, this is akin to a table. It's analogous to a table. It has a schema. In this case, it's the same as our connection. These are our fields. I'll get into some of these other attributes of the stream in just a bit. And you can actually see here that this is the wall clock time that Decodable saw these records. But you can, in descending order. So you can actually see that this is what these records look like. So these are inserts that have occurred. And we see the 3 records that have come in. And so you see ID 1, 2, and 3, and you will notice that they're out of order. This is something that sometimes people sort of miss in relational databases, but the tables themselves are not strictly ordered. You actually have to order a table on query to get any order that you expect. So we process these records as they flow in from the Postgres replication log, or the write-ahead log. And so that's what we're consuming off of and receiving these events. You'll notice that we're using this ID as our key. And the reason why that's interesting is because in CDC, anything with the same key is going to be, any updates are basically going to apply where they have the same key. And that's why that key winds up being important. It's also worth pointing out that Decodable is a distributed processing system. And so we actually could be processing different parts of the stream in parallel, which is a little bit tricky to think about, but this is why this stream has the notion of what we call a partition key. And I'm just gonna make this a little bit bigger. So when you specify a primary key, Decodable is smart enough to figure out, oh, we actually need to partition this data according to the primary key so that we group all records, together that have the same primary key. So here our ID field has been detected. You can see that records with the same values for the partition fields will be written to the same stream partition. And if you don't select any fields, then they're uniformly distributed. They're basically sort of spread evenly over all partitions of the stream, and that allows the engine to process in parallel. But here that would actually be incorrect. So what we do is we effectively partition or cluster by the primary key field. We're going to ignore watermark for now. There's lots of additional detail there. And zoom back out a little bit. But anyway, so that's why we see this ID broken out. Now, this is just physical information for the engine to keep track of this. The user doesn't have to think about ID as like a special field or a key or anything like that beyond sort of telling us that it's the primary key. We're going to lay the data out properly so that your processing works the way you expect it to. So just to sort of prove, I'm going to activate this so that it's streaming and scroll down. Just to prove that this is sort of still doing what we expect, let's update the users table and set the status to inactive, where ID equals 1. So we're going to deactivate user ID 1. And if we flip back over to Decodable, the UI is just polling the stream behind the scenes. You'll see that there's a new record for user ID 1 here. And if we expand this and scroll down, we can see that its status is now changed to inactive. And so basically this acts as like a ledger or effectively a version of the write-ahead log or the replication log. Okay, so this is what's low level, what's happening under the hood. You can see that we have a decodable pipeline set up, and this is a user domain counter, or at least that's what I called it. And so basically what this is going to do is it's going to take the data from our raw stream of records, and it's going to select the ID, email address, status, and updated date. We're going to ignore the created date here. And we're going to split the email address on the @ symbol and take the second field. This is 0 indexed, and call that domain. And then we take the result of that query, and we're going to make the domain plus the status, the user status, the ID, so a new ID, and then we're going to count the number of records by domain and by status. And you see they're here in our group by. If you know SQL, this is like pretty standard stuff, relatively straightforward. We're also going to take the maximum value of the updated date. So we're going to find the max. We're going to maintain the maximum value of the updated record, and we're going to call that updated date. So basically, we're going to count how many users are in which status by the domain of their email address, and we're going to remember sort of not just the count, but the maximum updated date. So this is where things get interesting. If I preview this, what will wind up happening is the Decodable is going to go back. It's going to not operate necessarily on the low level change data, capture data. It's actually operating on the logical records here. And so you can see it processed 30 changes, resulting in 2 records, and it did it in 8 seconds. And again, this is just showing us a sample of that data. What you can see here is that we found the net result of all the changes that have happened was that there is 1 inactive user for decodable.co, and then there's 1 invited user for gmail.com. And in fact, this is actually processing some older data. I had cleared out my table. So let's actually do this. Let's delete from users. Let's sort of wipe everything out again and run this. And if everything goes according to plan, we now actually see that old data, that Gmail is no longer there. So we count the records that have been applied here. So you can see all the same things. We have input records, we have output records, and that data is now flowing into a new output stream that is all of the changes now to those counts, right? So this is, where you see nulls, this actually represents deletes. So this is what the system uses to represent deletes internally, is these null records. And so that's sort of this is sort of a quick recap of the first portion that we did last time in our demo, just showing you sort of how you can process that. So if you want to learn more about what I just showed you, definitely check out the first portion. What I'm going to do now is I'm going to show you how you can take this data and write it back out to another system. So what I've done here is I've set up a new table. And so let's look at this inside of Postgres. So we have this user domain stats table. So we look at user domain stats, you can see that we have this ID, we have the domain, we have the status, we have our count, and we have our updated date. And so basically this looks like that result of the query that I just showed you, the results of the pipeline. And you can see that the primary key for this is set to be this ID. So if we sort of jump backwards just a sec and look at this output stream, this user domain stats v3, you can see we have the same schema here. The fields are in a slightly different order. That was just because I cloned something and sort of added the ID to the end. And our partition key again is set to the ID. And so that again means that all things that have the same domain and status are going to be rolled up. So they'll automatically update any existing record with the same ID. So if we look at this, again, in this example, I'm actually using the same database, but this could really be any other sync system that is supported by Decodable. It could be MySQL, it could be S3, it could be lots of different systems. But in this case, I've chosen the same database, just a different table in that database. So my source is going to be the users table. I'm going to emit a change data capture stream, processing that data in Decodable. And in this instance, just for example purposes, I don't know that you would do this in production, but like you could, we're going to write back to the same database, different table. And in this case, we're going to write to the user domain stats table. Now, Decodable is going to validate that the schemas are correct and all these other kinds of good things. We've seen that we're processing that data. What I'm going to do here is I'm going to, let's again, just double check that we have no records in users and that we have no records in user domain stats, right? So these two tables are both empty. That's the net result of all the operations that we've performed. And so what I'm going to do is I'm going to effectively do the same thing I did before. So I'm going to take these inserts and I'm going to insert into the users table. We'll do that. And again, I guess I can just create this table. Okay, so our records are there. Let's now check our user domain stats table. And so our user domain stats table has now been updated by Decodable as a result of doing all the processing that we're doing to parse out the domain and then count by domain and status. And we've taken the maximum of the updated date, which is 21/15/737, 21/15/737. So record 3 has the greatest timestamp, which is correct. Okay, that's good. So now, again, if we update user ID 1 to be inactive, we'll do that. And again, we can sort of double check that that did what we did. We see that user ID 1 is now inactive. And if we query the stats table now, we can see that the active user count is now 2 and our inactive count is 1. And again, the last updated time here is what we think it is, because this is based on sort of the updated time of these user records. And I guess what I probably should have done for our demos, I should have set it to be inactive and set updated date equals now, or user ID 1. So if we do that again and we query this, we can see that the timestamp has changed, the counts have not. So it basically works as we would expect it to. This is a relatively simple example, but you can imagine we could be doing all sorts of fancy processing. And because Decodable can write to systems other than just Postgres and MySQL and database systems like that, because they can write to systems like, well, just to sort of show you, because we can write to sync systems like Kafka and Kinesis and Pulsar and all these other kinds of systems, there could have been microservices that are receiving that data and doing things like ML inferencing, real-time scoring, writing the result of that back into Postgres. And the reason why that's interesting is that that would allow us to do things like serve product recommendations or to determine next best offers, or whatever the business logic is that is implemented in those microservices. If they're Lambda functions, or even just like more complex SQL statements inside of Decodable, where you can express the business logic there. Maybe you don't even need to build a microservice. Maybe you can really just use the SQL query to do that kind of processing. And so this is a way of computing things like stats or leaderboards in gaming. This could be, like I said, pricing adjustments inside of retail infrastructure. There's so many different kinds of applications that are really just doing some kind of function over the change of data that occurs in real time. So if this were inventory data, for instance, as users make purchase events, we could have decremented the count of things, which could in turn show up as changes to available inventory to users that might allow you to offer a user, like, hey, let's ship this to you, rather than having you drive to a local store to pick something up or something like that, or even suggest a different product. So this is just one way that you can continue to engage users by taking advantage of all of the real-time activity that's happening within the product today through something very, very simple of just like counting things and sort of, creating this materialized view back inside of the database that is the result of really sophisticated processing, or even sometimes simple processing that happens on the back end of the system. And again, just to sort of like play around with this a little bit, we could, let's do this. Let's insert into users, let's say user ID 4. And in this case, this will be eSummer4. This is me. This is going to be, let's say, eSummer4@gmail.com. So maybe this is a different, different domain, different user account. And this user, let's pretend that they're invited to an account rather than active. And our created date will be now, and our updated date will be now. And if we query our domain stats, we now see that there's one user from Gmail that's been invited. And if we then, let's update, and in this case, we're going to set that user to be active, or change. We'll remember to update the updated timestamp. Now we're going to do this for user ID 4, which is the one that we just inserted, and you can see now that we have one active user for Gmail. Let's pretend for some reason that user ID 4 now changes their email address, right? So now user ID 4 is no longer going to be a gmail.com user, it's going to be a decodable.co user. So we do that, and what we should see here is that this collapses into the active decodable.co user account. Right, so this is just an example of all this processing that's happening, on the back end asynchronously, and we didn't have to do anything really, really special to make that happen. And you can see that the record count has gone up here for our connection. We can look at, the most recent changes and walk, all the way up the dependency graph to see everything that kind of went into that. So our raw table, and finally our source system, we're up to 72 changes that have been received in the system. And that's it. That's how you can process change data capture data in real time, end to end, both from sources all the way through to the destination, using just some simple configuration and the SQL that you already know. You don't need to be a stream processing expert to be able to do this. If you're an application developer and you want to build real-time functionality into your app for retail, for logistics, for fraud and threat detection, you can do that right now today with Decodable and just some simple SQL. I really appreciate your time. I encourage you to try this at home. You can sign up for a free account of Decodable and try this on your database systems today. Just go to decodable.co. And if you have any trouble at all, you can join our community Slack channel or just email support@decodable.co. We're happy to help you out with any kind of challenges that you have. Otherwise, happy decoding. Thanks for watching.